Today I am going to be presenting the unit circle concept and practice problems you may be able to find with the unit circle. The unit circle is a circle that has an origin of 0, 0 and a radius of 1. Right here is the origin, 0, 0, radius of 1, unit, and it goes up to -1 on both the x and y axis. Let's take a look at the unit circle with radians and degrees. As you may see, you may think it's difficult to understand, but in reality, there's a shortcut to it. First, remember that you will replace the pi with 1, only 1, when dealing with fractions. Let's start with pi 6. Think about it as 1/6 right here. This equals to 30 degrees. So pi over 6 equals 30 degrees. Second, you would go to pi over 3. Think about it as adding 1 over 6 plus 1 over 6. That's 2 over 6. When you simplify 2 over 6, it's 1 over 3, which you would then replace the 1 with pi, and that would be pi over 3. For the degrees, you would just add 30 more degrees to 30, which that would be 60 degrees. So that being said, pi over 3 equals 60 degrees. Next, we go to pi over 2. Think about it as 3 over 6, 1 over 6, 2 over 6, and 3 over 6. When it's simplified, it's half. And the 1 is replaced with pi, and it's going to be pi over 2. So pi over 2 equals 90 degrees. When you add 60 and 30 to get 90. Next is 2 over 3. We left off with 3 over 6 right here, so you just add 1 over 6 to 3 over 6, and that would be 4 over 6. When you simplify 4 over 6, that would be 2 over 3. Add the pi to the numerator, and that would be 2 pi over 3 as said right here. For the degrees, you will add 30 more degrees, and that would be 120 degrees. So 2 pi over 3 equals 120 degrees. Then comes 5 pi over 6. Without the pi, it's 5 over 6. As you can tell, you can't simplify it so it stays the same with the pi added to the numerator. But for the degrees, you will just add 30 to 120. So it's 5 pi over 6 equals 150 degrees. Next comes pi itself right here. Since we started with 1, and then 2, then 3, then 4, then 5, then 6. 6 over 6 is 1 when you simplify it. You replace the 1 with pi, and it's pi. So you just add 30 degrees to 150, and that's 180. So then pi equals 180 degrees. This would go on for quadrant 3 and 4. If I finish all of it, it would take long. Now to the 45 degree angles. It starts off with pi over 4. You add 1/4 to 1/4, this equals 2/4. When you simplify it, it's 1 over 2. Replace the 1 with pi, and that's pi over 2, like we mentioned before. And for the degrees, you add 45 and 45, that's 90 degrees. Then it's 3 over 4 right here. Without the pi, it's 3 over 4, so it can't be simplified. It stays the same. 1 1/4, 2/4, 3/4. It stays the same. You add 45 degrees to 90 degrees, and that's 135 degrees. So 3 pi over 4 equals 135 degrees. It's 1/4, 2/4, 3/4, then 4/4. Like the 6 over 6, 4 over 4 equals 1. You replace the 1 with pi, and it's pi. You just add 45 degrees to 35 degrees, and that would equal 180 like said before. And so forth with third and fourth quadrant. This is just a shortcut to learning the unit circle for better performance in problems. Or there's always an additional way, but this way will take up more time on when working with a problem. This would be just by learning the radians or the degrees. That being learned, you can convert between both of those. To convert degrees to radians, you would multiply the degrees by pi over 8, 180. And to convert radians to degrees, you would multiply radians by 180 over pi. Now we will take a look at an example in converting degrees to radians. What is the radian of a 60-degree angle? As the equation said in the previous page right here, you would multiply 60 degrees by pi over 180. That would equal to 60 degrees over 180. When you simplify it, it's pi over 3. Or the fastest you can find this out with the memorization of the unit circle, in which pi over 3 is 60 degrees in the unit circle. Now let's take a look at the opposite, converting radians into degrees example. What is 270 degrees in radians? Referring back to the equation right here, you would have to multiply the degrees by pi over 180. In this case, 227 by pi over 180 is equal to 270 over 180. When you simplify it, that would equal to 3 pi over 2. Or like I said before, referring to the memorized unit circle would be quicker. Now let's learn about the coordinates as usual. Quadrant 1 consists of positive coordinates. Quadrant 2 consists of negative and positive coordinates. Quadrant 3 consists of negative coordinates. Quadrant 4 consists of positive and negative coordinates. This right here is the unit circle with corresponding coordinates. Memorizing this will make everything easier too. An easy way to remember is by remembering what each quadrant consists of, positive and negatives, like I said in the previous slide. And then just remembering 1, 2, 3 going down, 2, 3, 1, 2, 3 going up, 3, 2, 1 going down, 1, 2, 3 going down, 3, 2, 1 going down, 1, 2, 3 going down, 1, 2, 3 going up, 1, 2, 3 going down. This also refers back to the 30-degree, 40-degree, and 60-degree right triangle and geometry. Right here, the 60, 45, and 30-degree triangle, right triangle. If you form the line right here. These are the trigonometric functions to refer to when you're using the unit circle. Sine equals y over 1, or the radius, which equals to y. Cosine is equals x over 1 or r, which equals to x. Tangent equals y over x. Cosecant 1 over y or r over y. Secant 1 over x or r over x. Cotangent x over y. Using the unit circle to evaluate trigonometric functions. Sine 315 degrees. The angle passes through point square root 2 over 2 and negative square root 2 over 2 in the unit circle. 315 is right here. And if you remember, sine equals to y. So you would be looking at the y-axis. X, y, and your answer would be right here. Negative square root 2 over 2. Now let's look at another problem. This is tangent 180 degrees. The angle passes through the point negative 1, 0 in the unit circle, right here. Tangent is y over x. So when you put this y, the 0, over negative 1, that equals to 0. So tangent 180 degrees equals 0. And this right here is the unit circle with the corresponding coordinates, the radians, and the degrees.